we go, guys. I'm going to rewrite this just to give myself some room. All right. So the big thing about, first of all, you guys can hear me at home, right? Thumbs up, you hear me? All right. So the big thing about Friday's problems were solving trig equations with a period change. You basically just have to make sure that you prepare yourselves for more or less answers because they're only asking for answers between 0 and 2 pi. So the answers are limited to a specific interval of that function or that graph. So you want to make sure that when these period changes or these shifts take place, it could change the number of answers that make this equation true on the interval from 0 to 2 pi. So we always want to solve them by keeping in mind we have to prepare for more or less answers. All right. All right, so if we're going to solve this one, the first thing I would tell you guys is get the tangent of whatever equal to something by itself. Well, guys, it is. It's the tangent of this has to equal 1. So I don't have to solve for tangent. We're ready to go. So I asked you guys to basically fake solve it first. Pretend that it just said theta. If this was tangent theta equals 1, what angles would have made this true? Well, guys, think about it. If the tangent of some angle has to equal 1, you can draw your special triangles again. Does anybody know the tangent of what angle? If it was a quadrangle, like a pi over 2, a pi, a 3 pi over 2, or a 2 pi, the tangents were always zeros or undefined. So it's got to be an angle that fit inside of a right triangle, like a 30, 60, or 45. Does anybody know which one of them had a tangent equal to 1? It was pi over 4. It's a 45-degree angle. So now, according to all students take calculus, the tangent of an angle would equal a positive ratio in what quadrants? All take. So an angle in quadrant 1 has a positive tangent ratio, and an angle in quadrant 3 has a positive tangent ratio. All right, so there is a multiple of pi over 4 hanging out in quadrant 1 that would make this equation true. And there's a multiple of pi over 4 hanging out in quadrant 3 that would make this equation true. So guys, what multiple of pi over 4 is in quadrant 1? Pi over 4. But what multiple of pi over 4 is in quadrant 3? Guys, if this is pi, then that's 4 pi over 4. So who's the one that's 1 pi over 4 past it? 5 pi over 4. So that means the angles that would have made this equation true are pi over 4 and 5 pi over 4. But guys, those are only the angles that would have made it true if this was just theta. It wasn't just theta. It's theta minus pi over 2. So there's a shift here. So we need theta minus pi over 2 to equal pi over 4, one of the angles that would have made this true, plus the period. So we prepare for more or less answers. And what was the original period of tangent? Pi. All right, and then it could have been 5 pi over 4. So theta minus pi over 2 could have equaled 5 pi over 4 plus the period of pi. Now, I don't know if you guys remember from Friday, but the beautiful thing about tangent is because his period is so quick, his period is pi radians. Well, guys, these angles are pi radians apart. So you actually only have to solve the first equation, and then his second answer is his first answer. So tangent's nice in that he picks up all of the answers from the first equation anyway. All right, so guys, we have to solve this for theta. That means we have to add pi over 2 away. So add pi over 2 to the other side. But guys, add it to the angle, not the period. So add it to the angle, not the period. So add it here. And then you'll get theta will equal pi over 4 plus pi over 2. Well, guys, pi over 2 is 2 pi's over 4. So what's 1 pi over 4 plus 2 pi over 4? 3 pi over 4, and then that's plus pi. So guys, the first answer to this equation is 3 pi over 4. Now, they only want answers between 0 and 2 pi. And right now, it's looking like we're working with pi's over 4. So if we're going all the way around a circle, 0 to 2 pi, how many pi's over 4 make 2 pi? 8 of them. So as long as I stay between 0 and 8 pi over 4, these are angles that are going to be answers to this equation. So now we're just going to keep adding the period on until we get beyond 8 pi's over 4. So guys, 3 pi over 4 plus pi is 4 pi's. over 4. So 3 pi over 4 plus 4 pi over 4 makes 7 pi's over 4. Is 7 pi over 4 within that 0 to 2 pi range? Yeah, he's under 8 pi's over 4. So he's another answer, which means, guys, this is the answer you would have gotten when you solved this one. The second answer is his first answer. All right, add another period on. Guys, if I add another 4 pi over 4, wouldn't I be sitting at 11 pi's over 4? Is 11 pi's over 4 in that 0 to 2 pi range? No, he's too big. He's past the 8 pi's over 4. So he's not an answer. Your only answers to this equation are 3 pi over 4 and 7 pi over 4. So this one didn't have a period change. The period was always pi, but it had a shift to the right pi over 2 units. So you could have shifted more or less answers out of this range. All right, how do we feel, okay? All right, let's try another one. So now you can go to the top of the day 2 notes. And we'll do those 2 examples, and then we're going to stop. I gave you a little bit more room for these, but I still don't know if it's enough. And again, if you tried solving this, you would have added pi over 2. I don't know if I said this. 7 pi over 4 is who you would have got. So you don't have to solve them, but I always set it up. So I don't want to forget for the other problems to set it up.
Now we're on day 2.
Now we're on the top of day 2. I hope you get these 2 examples done, and then we're stopping. I'll do these on Wednesday. All right, so here we go. Same thing. Solve each equation on the interval from 0 to 2 pi. So they are asking you to solve these. Now, you only are allowed to list answers in between 0 and 2 pi. Guys, look, it's the cosine of, look at all this stuff that happened to the inside of the function. That could affect the period. That could affect a shift. So it definitely could affect the number of answers that are now fitting in between 0 and 2 pi. Sometimes this change could make more answers between 0 and 2 pi, and sometimes this change could make less answers between 0 and 2 pi. All right, here we go. So let's get cosine by itself. Well, guys, it's the cosine of this equals -1. So cosine is by itself. So that part's done. Now we're going to fake solve it. Pretend that it just said cosine theta equals -1. All right, well, what angles make this true? If this was just cosine theta equals -1. Well, guys, your cosine ratios are usually 1/2, √3 over 2, √2 over 2. If you picture those x coordinates on the unit circle. So for the cosine to be equal to -1, that's a special angle. That's a quadrantal. It's a 0, a pi over 2, a pi, a 3 pi over 2. So picture your unit circle, 1 unit in each direction. We know the cosine of an angle is represented by the x coordinate. So what special point, what special angle had an x coordinate equal to -1? Right there. And what angle fell right there? Pi. So right now, there's only one angle that would make this equation true if it was just cosine theta. All right, and it would be pi radians. But guys, it's not cosine theta. I need this to equal pi. So I need 2 theta minus pi over 2 to equal pi radians, and then we're going to add on the period of cosine to prepare for more or less answers. So plus, guys, what was the original period of cosine? 2 pi. So that's how we set it up. Now the good news is, because only one angle from 0 to 2 pi made this true, there's only one setup. I don't have another angle to set up a second equation. All right, so guys, we got to solve this for theta. So first we're going to add the pi over 2 away. This is an angle, a shift, right? So add it to the angle, not the period. So add pi over 2. And what do we get? We get 2 theta equals, well, guys, pi plus pi over 2. This is 2 pi's over 2. So 2 pi's over 2 plus 1 pi over 2 is 3 pi over 2. Plus the period of 2 pi. All right, now to get theta by itself, I have to divide by 2. But it's actually easier to times by 1/2. And then I'm going to times this side by 1/2. So this one will actually affect the period and the angle. So in the end, theta actually has to equal what's 1/2 times 3 pi over 2. Top with top, bottom with bottom, 3 pi over 4. Plus 2 pi times 1/2 is pi. So this one has a new period. The new graph would only have a period of pi. All right, so guys, technically, here's your first answer. 3 pi over 4 is the first angle that would make this equation true. So if we are dealing with pi's over 4, all the way around is 2 pi radians. So in the world of pi's over 4, how many make 2 pi? 8 of them. So as long as I stay under that 8 pi over 4 mark again, these are all going to be answers to this equation. So 3 pi over 4 definitely fits. He's our first answer. Now we just have to keep adding this new period on until we get past the 8 pi over 4 mark. So guys, pi is 4 pi over 4. So add another one on, you're at 7 pi over 4. So it's almost just like the last problem. All right, that's another answer because he falls before 8 pi over 4, so he'll be in that 0 to 2 pi range. Guys, if I add another period on, what angle would I be sitting at? 7 pi over 4 plus 4 pi over 4 is 11 pi over 4, which is definitely too big. So I don't have to add another one on. These are the only two answers from 0 to 2 pi that would make this equation true. All right, everybody, and guys, it makes sense because if it was a normal problem, it only had one answer from 0 to 2 pi. So when I've doubled, right, the number of answers in this problem, it would have double the answers. Now it has two answers from 0 to 2 pi. All right, here we go. Last one. The tangent of theta over 2 plus pi over 2 has to equal 1. So guys, a ton of stuff has happened to the inside. So you know this could have a period change, and that could affect the number of answers that we get. So we'll prepare for more or less. I would normally tell you to get tangent by itself. Guys, tangent is by itself, so we're ready to go. Let's fake solve it. If this just said tangent theta equaled 1, well, remember, if tangent of a quadrantal would have been zeros or undefined. So if the tangent equals a ratio other than 0 or undefined, it's a special angle. It's 30, it's 60, it's 45. Does anybody remember the tangent of what special angle is 1? Just did it. 45. So it's definitely 45. And the ratio is positive 1. So according to all students take calculus, all in take, the tangent of an angle in quadrant 1 would have a positive ratio, and the tangent of an angle in quadrant 3 would have a positive ratio. All right, so we have a multiple of pi over 4, right? The tangent of an angle that has a ratio of 1 is a 45. So there's a multiple of pi over 4 in quadrant 1 that makes this true, and there's a multiple of pi over 4 in quadrant 3 that makes this true. Well, the multiple of pi over 4 in quadrant 1 is pi over 4, and we just did this in the other example. What multiple of pi over 4 falls in quadrant 3? 5 pi over 4. This is 4 pi over 4. This is 5 pi over 4. So those are the two angles from 0 to 2 pi that would have made this true if this was just tangent theta, because it wasn't tangent theta. We need this to equal pi over 4. We need this to equal 5 pi over 4. So let's set up our equations. So I need theta divided by 2 plus pi over 2, right? Is that pi over 3? Is that 3? Is it 3? Yeah, plus pi over 3. I need that to equal pi over 4, plus, let's prepare for more or less answers. What is the original period of tangent? Pi. All right, and then I need theta over 2 plus pi over 3 to equal 5 pi over 4 plus the period of pi. But guys, remember the beautiful thing about tangent. Because his period is so fast, it's only pi radians, it's not all the way back around. I know that my second answer to this is the first answer I would have gotten to this. So I really don't have to solve the second one. I really only have to solve this one, and I'll pick up all the answers from him. All right, so here we go. Let's get theta by itself. So let's minus the angle. So minus the angle from the angle, not the period. You end up with theta divided by 2 equals, get a common denominator of 12. This would be 3 pi's over 12, and this would be 4 pi's over 12. So 3 pi over 12 minus 4 pi over 12 is negative 1 pi over 12. And then plus pi. Is everybody okay with that? I didn't write the common denominator down, but it becomes 3 pi over 12 minus 4 pi over 12. All right, now we got to get theta by itself. So I have to times both sides by 2. So then you end up with theta will equal 2 times negative pi over 12. Well, guys, 2 over 1, 2 and 12 reduced to 6. So this becomes negative pi over 6 when you times it by 2. And then plus 2 pi. So now you've stretched this graph horizontally. So now it takes 2 pi radians to create one tangent curve, not pi. All right, so guys, technically, right now, this is your first answer. Does anybody have a problem with that being your first answer? It's negative. It's not in between 0 and 2 pi, right? So technically, we have to start with him, but we're not going to include him in the end. We're going to start with him and keep adding that period on, but you can't include him. He's not between 0 and 2 pi. All right, so we'll start there, but we really know he's not an answer. All right, so we have to take negative pi over 6 and add on the period of 2 pi. Well, 2 pi becomes, what, 12 pi's over 6 in the world of 2 pi's? So now keep adding 12 pi's over 6 on. So guys, what's negative 1 pi over 6 plus 12 pi over 6? 11 pi's over 6. And if we're working from 0 to 2 pi, that takes 12 pi's over 6. So as long as you stay under 12 pi's over 6 and bigger than 0, you got winners. So he's out, but he's in. But guys, if you added another period onto him and another 12 pi's over 6, aren't you sitting at 23 pi's over 6? That's way past 12 pi's over 6. So he's not an answer. So the only answer to this equation is 11 pi's over 6. All right, so his first one was bad, the next one was good, and this is the answer you would have gotten if you solved this one. All right, so 11 pi over 6 is the only answer to this equation. There's only one angle because, guys, you've literally horizontally stretched it. You take more angles to create one tangent curve now. So only one angle fits in between 0 and 2 pi. Does that make sense?
Yeah.
Okay. All right, so, guys, that's where I want to stop. If you look at the other ones, same thing. They're more trig equations, but they have a quadratic form. So I'll leave you with a little bit of a spoiler. Guys, think about how we solve quadratics. We love to factor. So there might be some factoring involved when you get to these trig equations that have a quadratic form, okay? All right, thumbs up at home, guys. A lot of cameras off at home. It's not a good sign. It looks really bad on your part. I'm just letting you know. I did not create another homework. I'm giving you guys tomorrow a virtual day to work on the homework that I created for all of these types of trig equations with the period change. It's due tomorrow night at 11:59, I believe. But if anybody had trouble or not enough time, just let me know. I can always extend it. But there will be no Google Meet tomorrow. Everybody stays home. You can just work on your homework that's due. Everybody okay? All right. All right, let me take attendance at home. Oh, cameras are on now. All right, let's see.